Hi, in this video we are going to discuss about Kruskal's algorithm. So what is this Kruskal algorithm is for? This is to find the minimum spanning tree in efficient way. So what is minimum spanning tree? So let's take an example graph. Consider Considered I have a graph like this, undirected graph. I have 5 vertices and all the vertices are connected using the edges, right? So now I have A, B, C, D and E vertices, right? And this is undirected graph. Undirected graph means there is no direction specified. So this edge is to connect A to B as well as B to A. So take this example, right? So what is minimum spanning tree? So spanning tree, what is spanning tree? So spanning tree is I have to have a outcome graph in which I have to connect all the vertices with minimum number of edges, right? So spanning tree, for example, this is a graph. This can be one spanning tree. So you can understand all the vertices are connected. All the vertices are connected. This is one sample spanning tree. So another spanning tree could be this can be another spanning tree. So here also all the vertices are connected, all the nodes are connected. So this is what a spanning tree. So for a particular graph I can have n number of spanning trees. So what is minimum spanning tree? Out of the all possible spanning trees, which one gives me the minimum cost? That is, each edge has its own cost for it. So the spanning tree which has least cost is considered as a minimum spanning tree. So it has its own application. See, for example, if I want to do a wiring for my building or a room or something, right, I need to use the wires to connect all the points, right, electrical points. So in which I can consider each vertices as an electrical point, and this can be the wire, edges can be the wire. So the least cost spanning tree will give me the least cost wired for my wiring the building or any particular room or something. So that is one application. So like that we have many applications for this minimum spanning tree. So we have two algorithms to solve this minimum spanning tree. One is called the Prim's, other one is the Kruskal. So the Kruskal actually comes under greedy method. So it will consider the local optimal solution to find the minimum spanning tree. See, let's take an example of the same graph. How can I find the minimum spanning tree for this particular graph using the Kruskal algorithm? So what should I first do is, I have to take all the edges and I have to sort the edges in the ascending order, right? See, I have the nodes A, B, C, D, E. So I am taking the pair of vertices connected by the edges, and I am going to sort the edges in the ascending order. So which is very least cost is A to E first. So A to E with the cost 1. Then C to E with the cost 1. Then A to C with the cost 2. Then E to D to E with the cost 2. Then A to B with the cost 3. Then C to D with the cost 3. Then B to E with the cost 4. Then finally B to D with the cost 6. So 1, 2, 3, 4, 5, 6, 7, 8. So number of edges, and I sorted in the ascending order. Now I have to introduce the edges one after another into the empty tree. So you have to take an empty tree like this. Only I will be having all the nodes without having any edges. Now I am going to introduce the edges one after another into this empty collection to make it as a spanning tree, and using this I can find the minimum spanning tree. See, first edges A to E. So what is the rule? I am going to include the edges one after another into this empty tree. When I am including this, what is the point I need to consider is it should not make a cycle. See, here in this two example you can see, right, that there should not be any there should not be a complete cycle. Even I can have a spanning tree like this without this edge. All the nodes are connected. Without this edge, all the nodes are connected, right? So I should not have any cycle in the tree. It is not mandatory, because what a spanning tree is, spanning tree means all the nodes should be connected, right, in one or in another way. It need not to be fully connected, right? All the nodes should be connected. That's it, right? So weakly connection is enough. That is what a spanning tree. Minimum spanning tree should give me even very less cost to connect all the nodes. So if I have n number of vertices, right, I should have n minus 1 number of edges to connect all the nodes. Correct? If I have 5 nodes, I need only 4 vertices. So this vertex is even not required. This vertices is not even required, right? So if I have 5 vertices with me, I need minimum 4 edges to connect all the 5 vertices. So this is enough. This is enough for being a spanning tree. So what is minimum spanning tree? With the n minus 1 number of edges, I need to connect with the least cost. That is what minimum spanning tree. So what is the point here you can consider is it should not make a cycle, because if I make a cycle, what happened already? I told this is one spanning tree. So what happened? This will be an additional cost for me. So I need not to have the cycle. So there should not be a cycle. No cycle. It should not create a cycle. So that is we need to consider when we are including the edges one after another into this empty tree. So first I am going to start with the least cost A to E. So when I am including this edge, into the collection of nodes, right, I need to consider is that any cycle is forming. So here there is no cycle formation. Then I need to consider C to E. So I am including C to E and I am checking whether a cycle is created. No. A to C. So if I include A to C here, it will create a cycle. So I should not include this edge. D to E. D to E with 2. If I am including this, it will not create a cycle. A to B. If I am including A to B, it will not create a cycle. C to D. If I include C to D, then it will create a cycle. B to E. If I include B to E, it will create a cycle. B to D, it will create a cycle. So what is the meaning of cycle? So it will start from one node, then you can traverse and you can get back the same node. That is what a cycle in a graph. So I should not have a cycle. So this is what the minimum spanning tree for this particular graph using the Kruskal algorithm. So I ignored a few points. So A to E I included, C to E I included without forming cycle. A to C I cannot include because it's creating a cycle. D to E I can include. A to B I can include. C to D will create a cycle, so I am ignoring this. B to E will create a cycle, so I am ignoring this. B to D is also creating a cycle, so I am ignoring this. So this is the minimum spanning tree, MST, minimum spanning tree using Kruskal algorithm for this particular graph. So what is the algorithm designing technique here I am using is, as I told, the greedy method. So why it is greedy? Because every time I am looking for only the local optimization. What is the result of my next step? If I include A to C, what is the result? It creates a cycle, so I am ignoring it, right? So next step, if I am including A to B, it's not creating a cycle, so I am including this. And I have sorted this, so I am assuming that since I am sorted using the cost of each edges in the ascending order, so I am including one after another in this order, so it gives me the least cost. So what edges I am ignoring is when it create a cycle. So this comes under the designing technique called greedy method. It's looking only for the local optimized solution. But most of the time, what is the disadvantage in the greedy method is it is not looking for the future consequences of the decision what I am making now. right? If I include A to B, it may mislead for me, right? Sometimes even I get better MST than this, since I'm not considering what is the future consequence of the decision what I made now. So that is a disadvantage in the greedy method. So we have other designing techniques called dynamic programming or something, right, where they are considering all the possibilities so that it will avoid the misleading of solutions. You can get the correct optimal solution. So this is what your Kruskal algorithm. So the Kruskal algorithm is to find the minimum spanning tree. So what is spanning tree? I need to cover all the nodes with less number of edges. That is what spanning tree. For a particular graph, I can have many number of spanning trees. You have to a n possible number of spanning trees I can create with different possibilities. And what is our point we are considering is it should not create a cycle, because we are looking for the minimal number of edges to cover all the vertices. So if it creates a cycle, means it's unnecessary one additional edge we use to connect the node. So we can avoid making the cycle when you are trying to find the spanning tree. What is exactly minimum spanning tree is, out of the spanning trees I have to come up with a spanning tree with less cost. So what we are using, you can use Prim's algorithm or Kruskal. So here we are discussing Kruskal algorithm. So what is Kruskal means? I have to take all the edges in the sorted order, right, in ascending order. Then I try to include, I have to have an empty tree, like having only the vertices without any edges. Now I am going to include the edge one after another into this empty set. Whenever I am including the edge into the empty set, what the point I need to consider is it should not create a cycle. If it is creating a cycle, I should ignore this. So in this way I have to progress for all the edges, right? Now this is the output I am getting. So for connecting all the 5 vertices, I need 4 edges. As I told, n vertices means n minus 1 number of edges. That too with the least cost. In total 7 is a cost for connecting all these vertices, right? Thank you. We will take another one example to find the minimum spanning tree. So consider this is a graph, right? Again the undirected graph, right? So here there is no direction specified, weighted undirected graph. So now, as I said, first I have to have an empty tree where I should have only the vertices without any edges. And the next step, I have to sort all the edges one after another, right? So I have to start from A to C. So A to C with the cost 1, then A to B with the cost 2, then D to E with the cost 2, then A to F with the cost 3, then B to E with the cost 3, then C to D with the cost 4, C to F with the cost 4, then A to D with the cost 5, then B to D with the cost 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. So now I have sorted all the edges according to their cost in the ascending order. Then I have the empty vertices here, right? Now I have to include the edges one after another, and I need to take the minimum cost edge to be included without creating a cycle. If it creates a cycle, I should ignore that edge. So A to C, I'm including, it's not creating a cycle. A to B, I'm including, it's not creating a cycle. D to E, I'm including, it's not creating a cycle. A to F, I'm including, it's not creating a cycle. B to E, I'm including, it's not creating a cycle. C to D, if I include this will make a cycle, so I should ignore this. C to F, if I include C to F, it will create a cycle, so I should ignore this. A to D, if I include A to D, it will create a cycle like this, so I should ignore this. B to D. The same way if I include B to D, it will create a cycle. So I should ignore this. So this is my resultant spanning tree with a minimum cost using the Kruskal algorithm. Right? So what is the total cost? Sometimes they will ask what is the total cost for finding the minimum spanning tree. So here it is 1 plus 2 plus 2 plus 3 plus 3. So 5, 8, 11 is the total cost for finding the minimum spanning trees for this given graph. Thank you.